Hi, let's continue and let's look into what is a complex number. Well, let's continue with the problem above, and the problem was solving x squared equals negative 1. Now, notice here that when you solved x squared minus 1 equals 0, you can also come over here and solve it this way. You could say that this is x squared, we'll just start here, equals 0. We add 1 to both sides. I have x squared equals 1. So now we take the square root of both sides. Well, notice though that there's going to be two answers. So you have, when you're solving a second degree, a quadratic, where there's an x squared, there's going to be two answers when you do use this method, a plus and a minus. And that's, so we say that x equals plus or minus the square root of 1, which is 1. So now, we're going to have to keep that in mind. When we solve x squared minus 1, we're going to take the square root of both sides. So we're going to get a plus and a minus, and then we're going to have this, the square root of negative 1. Well, on the left-hand side, we have an x equals, and then we get the plus or minus, and the square root of negative 1, this strange concept, is what we call I. And so, any number that has I in it is considered a complex number. So let's take a look at what they are. A complex number has, we'll write it down here, the general form has a general form of a plus ib, or you might see some books use x plus I y. Same thing, and let me explain. Okay, the a, b, x, and y can be any real number, can be any real number. Meaning it can be a square root, it can be a rational, it could be a whole number or an integer, it could be anything you want it. Any real number. Okay. Now, let's see, the part without, I'm going to, excuse me, the part without I is called the real component. And the part with I, part with I, is called the imaginary component. The imaginary component. For example, suppose we have something like this. Suppose we have the number 3 minus 2i over 4. Okay, well, 4 is a common denominator, so we can say that this is 3/4 minus 2/4 I, and then 2/4, we already know that that simplifies 3/4 minus 1/2 I. So we say that the real component is 3/4, and the imaginary component is negative 1/2 I. Okay, so let's try this. We're going to add and subtract some complex numbers. So here's our complex number that we're going to work with for our example. And the directions would be what you would expect. Simplify. Simplify. Let's try this one. The first one is 3 minus 5I plus, let's try minus 1 minus 2I. Now let's add those. So when we do this, I wrote it here with the parentheses just to show you that those are two complex numbers. Now, but when we add them, we can move around the part. So I'm going to drop the parentheses. Oops, I'm going to write this minus 1 minus 2I. And then we simplify it, we just combine like terms. So the i's are like terms, and those without i's are like terms. So we just combine like terms. And so just for the sake of illustration, let's group them. So I have a 3 minus 1, that's the real component. And then I have a minus 5i minus 2i as my imaginary component. So when I add the 3 minus 1, I get a 2. And then when I add the negative 5i minus 2i, I come up with minus 7i. Okay, let's try one more. Same idea, simplify, but we're going to just change it oh so slightly. How about 3 minus 5i? Now we're going to change it to minus negative 1 minus 2i. And let's see what happens. So without the parentheses, I would have 3 minus 5i. Now, as you would expect, we distribute the negative sign. So I would write this as plus 1 plus 2i. And then, to show you, let's regroup the like terms. I'm going to have a 3 plus 1 and a minus 5i plus 2i. So when I combine all my like terms, I have 4 minus 3i. And that is how we combine like terms. Now, let's take a look at I for a moment. For example, we know that I is just the square root of negative 1. And once you have the square root of negative 1, you always just use I. So let's start over. But this time we're not going to worry about our square root of negative 1. Let's just deal with the I. Or write it this way. So we have I. Now, what happens if we take I and we square I? All right, let's do this. Let's think of this as negative 1 to, well, yeah, this will work. Let me do it this way. So if I square I, that's the square root of negative 1 squared. And we already said that if you square a square root, the exponent and the radical go away. So I squared is negative 1. Let's try another one. How about I cubed? So I cubed is, well, I'm going to break it up into what I know. I know what I is, and I know what I squared is. Now remember, we leave I as it is. We don't change it back to the square root of negative 1. So this becomes I times I squared. But from above, we just discovered that's negative 1. And so I cubed is negative I. Now let's try I to the 4th even. And we're going to use what we've already learned. I to the 4th, you could think of that as I squared times an I squared. Well, that's negative 1 times negative 1. That's simply 1. And, or you also could have done I to the 4th as an I times I cubed. Or you'd have I times a negative I. And then this would give you a negative I squared. And I squared is negative 1, so you have minus negative 1, and again, you're back to 1. Well, let's try this one more time. Let's try, well, maybe a couple. how about I to the 5th? Well, I'm going to write that using what I know from above. I have an I to the 4th times an I. That's the same as I to the 5th. I to the 4th is 1 times I. That's just I. Huh. What about I to the 6th? Well, I could write that as I to the 4th, and the reason I'm looking for I to the 4th is because those are just 1. It's a very easy number to work with. Times an I squared. Well, that's just 1 times negative 1. So that's just negative 1. What about I cubed? Well, I cubed is, or I'm sorry, not I cubed. How about I to the 7th? Well, I to the 7th is an I to the 4th times an I cubed. So this is the same as saying 1 times negative I. Well, that's just negative I. And what if we go even higher? I to the 8th. Well, that's just I to the 4th times an I to the 4th. Or you could also think of it as an I to the 4th squared. But that's just 1 squared. So it's just 1. And the point of this is that the pattern of I repeats. So it just repeats every group of 4. So the next place we would expect the pattern to continue. And if we did, we'd say, well, I to the 9th, that would just be I to the 10th. That would just be negative 1. I to the 11th, that would be a negative I. And I to the 12th, that's a 12, would simply be back to 1 again. And this just continues on and on. So let's try one more concept. What about a big one, like I to the 115th? What is that? Well, here's an easy way to do. I to the 4th is 1. So how many I to the 4ths are there in 115? Well, let's see. Let's just do a little arithmetic. This is 4 goes into 11 2 times. That's going to be an 8. We're just doing simple addition or division. 35. It goes into that 8 times. That's 32. Subtract, I get a 3. So it's 28 remainder 3. So in other words, here's how we can use this. I to the 100, I'll come over here, or below. I to the 115th is the same as taking I to the 4th, 28 of those. But I to the 4th is 1, and 1 to the 28th is still 1. So times an I cubed. That's the same thing. Well, I to the 4th is 1. 1 raised to the 28th times an I cubed. Now from up above, we found that that's just negative I. So 1 to the 28th is just 1. 1 times negative is 1. I'll write that out. Times negative I, which is very simply negative I. And that is the beginning of adding, subtracting, and working with powers of I. Thanks for watching.